average rate of change. And conceivably, this first sentence on the notes is the most important sentence on the whole paper. What it says is it says you're already familiar with the concept of average rate of change. When finding the slope of a linear function, you're actually finding the average rate of change. So we worked with slope yesterday, and we're still going to be working with slope today. We're just going to call it average rate of change. So the process is going to be the same. So I think that sentence is really important there. But as we take a look at our first picture here, it says, using the graph below, find the average rate of change between the following intervals. Well, the first one is going to be between 0 and 3. And it says x is between 0 and 3. And if you look here at 0, we've got a point on our graph. And at 3, we've got a point on our graph. And if you remember that slope is defined as rise over run, we could draw a triangle in there. And what we see is that we rise 2 spaces and we run 3 spaces. So our average rate of change for that line is 2/3. Did I forget anything? Jordan? I forgot to put a negative in. As we're coming from the left, our line is going downhill. It's a decreasing line. So it's going to be negative 2/3. But there's our first interval. If we go to our next interval here, it says that x is between 3 and 6. So let's draw a triangle, again, between those 2 values, between 3 and 6. And what we know is that slope, or average rate of change, is rise over run. Is this one negative as well? Yes. Coming from the left, our line is going downhill. It's negative. Well, our third value here, 0 is less than or equal to x is less than or equal to 6. X is between 0 and 6. We're going to look from here to here. So we can start at this value and we can go to this value. But remember that average rate of change, like slope, is rise over run. So we rise 1, 2, 3, 4. We run 1, 2, 3, 4, 5, 6. Our line, coming from the left, is going downhill. This is still negative. Can we simplify 4/6? And we can. If you can't do it in your head, go to alpha y equals number 1, and 4/6. I know I didn't type in the negative, but 4/6 will give us 2/3. So once we type in 4/6, we see 2/3. I forgot to type in the negative, but we can still write that back in here. When we simplify this, this becomes negative 2/3. And what do you notice about all 3 of those average rate of change, Tiffany? They're all negative 2/3. In fact, we can say, what do you notice about the slope over the different intervals? The slope is the same. And I should say, I put the slope, I should have said the slopes are the same. But I'll do better here with my next sentence. What can be said about the average rate of change of a linear function? Well, in a linear function, the slope, or the average rate of change, I better use, is constant. In a linear function, the average rate of change is constant. That's for a line. You get negative 2/3 everywhere on a line for the slope, for the average rate of change. But we don't have to have the same value every single time. The process for computing the average rate of change is the same. For nonlinear functions, it's the same as finding it for linear functions. We pick 2 points, and we use the slope formula. So as we look over here, here is a nonlinear function that we want to find the average rate of change. So we're going to have to come up with some values here. And our first interval that we're looking at is x is between 0 and 4. So when we look on here, here's 0, 1, 2, 3, 4. Let's find those corresponding values. We've got a point right here, and we've got a point right there. Our first point is 0, 1. And our second point is 4, 1, 2, 3, 4, 5, 6, 7. 4, 7. And we're going to put this back into the slope formula. So remember, here's x1 and there's y1. Here's x2 and there's y2. We're calculating the average rate of change with the slope. 7 minus 1 over 4 minus 0. 7 minus 1 is 6. 4 minus 0 is 4. And if we wanted to, we could reduce that fraction, simplify that fraction to 3/2. 6 divided by 2 is 3. 4 divided by 2 is 2. But we get the idea. If we look at the next value here, we're going from the interval of 4, 5, 6, 7, over here to 7. And we already know what the value is here. It's coincidence that it's 4, 7 in our intervals 4 to 7. But over here at 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 7, 10. And once again, we're going to put this to calculate the average rate of change or to calculate the slope. What we're doing is we're x1, y1, x2, y2. And we fill that back in. And we end up with 10 minus 7 divided by 7 minus 4. Well, 10 minus 7 is 3. 7 minus 4 is 3. And what does 3 divided by 3 equal? 1. So we're going to do that one more time. Our interval this time is 7 over here to 13. We already know what the value of 7 is, it's this point here. It's 7, 10. And then here at 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Our ordered pair is 13, 15. And we're going to put those values back into our slope formula to calculate the average rate of change. So this time it's going to be 15 minus 10 divided by 13 minus 7. And 15 minus 10 is 5. 13 minus 7 is 6. Can we simplify that at all? No, we can't do anything else. Well, what do you notice about these average rates of change? Probably they're not the same. And we can even say that if they're not the same, that the average rates of change, spell it right, are different. When they're in different intervals, too. I mean, what do you notice about the average rate of change over the different intervals? Well, they're different. But the thing is, these are non-linear. In a line, they're all the same. In a non-line, they're not all the same. So non-linear functions have different rates of change. So it says draw lines connecting each point to the next. You may or may not want to do this in yours, just because you don't have a straight edge with you necessarily. So what I'm going to do is I am going to use my straight edge button here the best I can. And my first color was this blue. So we can draw our lines connecting each point to the next, from there to there. And then I went and did green. So let's go from there to there. Ooh, shoot. Let's see if we can fix it a little bit. Good. And then my third color was red. And when we draw our picture here, we'll go from there to there. So it's still, even with a straight edge, so to speak, up here, it doesn't look that good. So it's kind of one of the reasons why I don't use that button very often. But it says, draw the lines connecting each point to the next. So I've done that. What do you notice about the slope of each line and the average rate of change over the same interval? Well, we can go back to what we did at the first problem there. Rise over run. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There's our 6/4. And then in our next, we've got rise. 1, 2, 3. 1, 2, 3. Rise over run. 3 over 3. And finally, we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 5 over 6. What do we notice about the slope of each line and the average rate of change over the same interval? We notice that the slope and the average rate of change are the same. The slope and the average rate of change are the same. So when we find the average rate of change, we're finding the rate at which the functions, the y values, the outputs, are changing compared to the functions of the x values. And what we're going to look at now is the formula for average rate of change in function notation. And what it is, it's f of b minus f of a over b minus a. Well, the fact of the matter is, average rate of change is another way of saying slope. So this is another way of writing our slope formula, which is y2 minus y1 over x2 minus x1. What I'm going to do to finish today is I'm going to use this formula to finish. We're going to use the function notation to finish these kinds of problems. So if we look at, consider the following function, f of x equals 2x squared minus 10. Calculate the average rate of change for the function over the following intervals. Start left on your paper so you've got enough space. And the first thing to do is you're going to write down -2, and then I'm going to leave some space. We don't have a graph where we can look back and find the point. We have an equation that we now have to use to help us find our value. And then our next point is going to have 3, and then I'm going to leave some space there. Because we need to find that other value. We don't have a picture that we're looking at. What we're going to use is we're going to use this function over here, 2x squared minus 10. So to start, we're going to do f of -2. So we're going to put that value of -2 back into our function wherever we see x. 2x squared minus 10. Shouldn't be unfamiliar to you. We'll take this value of -2 and we're going to put it in here for x. Be careful if you're using your calculator. You need parentheses around the -2. This is going to be -2 squared. So it's 2 times -2 squared minus 10. -2 squared means -2 times -2, which is +4. And you can still type it in. But oftentimes people forget the parentheses and then it gets confusing. So this is 2 times 4 minus 10. And 2 times 4 is 8 minus 10. And 8 minus 10 is -2. That value is going to go back up here. It is coincidence that it's still -2. Strictly coincidence. But now what we have to do, by the way, what we just figured out is that that was f of a. But now what we want to figure out is, well, what does f of 3 equal? So this time it's going to be f of 3. And we're still going to put it back into the function that we're given here of 2x squared minus 10. We're going to take that value of 3. We're going to put it back into our function wherever we see x. So this becomes 2 times 3 squared minus 10. And when we type that in, remember that 3 squared is 3 times 3, which is 9. So it's 2 times 9 minus 10, which is 18 minus 10, which is 8. When we solve that, what that is that's the value of f of b. So we're going to put that back in here. And now to complete this problem, what we want to figure out is what is the average rate of change. Now we have the information that we need. This is A, this is f of A. Here's B, and there's f of B. And we're going to fill in the formula. F of B minus f of A divided by B minus A. Fill in our values now. F of B, 8, minus f of A, negative 2, divided by B, 3, minus A, negative 2. Double negative gives us a positive. Here and here. And when we do, 8 plus 2 is 10. 3 plus 2 is 5. And finally, our average rate of change will be 10 divided by 5 equals 2. That's our average rate of change. Average rate of change is the same thing as slope. The hard part about these problems is that we have to figure out the other value. On the front, it was nice. We could look at our picture and we could find the ordered pairs and we could use our formula. Now we have to come up with the value. And when we start here, what we've got is we've got a 5. We're going to find the other value. And we have a 9, and we have to find the other value. So we're going to put the value of 5 back into this function and compute the value. We're going to put the 9 back in this function and figure out what it is. So on this first case here, it's going to be f of 5. We're going to put that back into 2x squared minus 10. So our value of 5 is going to go in here. So it's 2 times 5 squared minus 10. Remember that 5 squared means 5 times 5. So this is 2 times 25 minus 10. And 2 times 25 is 50 minus 10, which is 40. Well, secondly, we need to deal with the 9. So this time we're going to figure out, well, what does f of 9 equal? We're still going to go back into our function that's given in the problem, the 2x squared minus 10. We're going to take that value of 9. We're going to put it back in here. So it's 2 times 9 squared minus 10. 9 squared means 9 times 9. Well, that's 2 times 81 minus 10. And 2 times 81 is 162 minus 10, which gives us 152. I didn't do very well labeling. I'm going to go back and label it so that hopefully it'll make sense for you. This is f of a. It's 40. We're going to put it in right here. Over here, this is f of b, 152. Don't get concerned about too big of numbers. It's okay. And now we're going to take those values and we're going to put them back into f of b minus f of a divided by b minus a. The formula that's right there in the box above your problem, that's our change in output over the change in input. Here's a. Here's f of a. B. F of b. And fill it in. 152 minus 40 divided by 9 minus 5. 152 minus 40 is 112. 9 minus 5 is 4. And if I've divided correctly, that gives us 28. That's our average rate of change. But we had to do a little bit of work to get there. We had to find the missing values of our points to be able to calculate that. As we finish, on our next problem, we have a table. And it says the table below represents a linear function. Find the average rate of change between the interval 5 to 19. Well, the good news is it's linear. So remember in linear that our average rate of change is constant. But what it says here is it says we want to look between 5 and 19. Well, 5 has a y value of 1. And 19 has a y value of 22. When we compute the average rate of change, we simply are computing the slope. So whether you look at it as f of b minus f of a divided by b minus a, or you look at it as y2 minus y1 over x2 minus x1, either way, the computation is the same. 22 minus 1 over 19 minus 5. 22 minus 1 is 21. 19 minus 5 is 14. And if we simplify that fraction, 7 goes into 21 3 times, and 7 goes into 14 twice. That's our average rate of change.